You are welcome to today's class. So today our focus is going to be on how to derive the general quadratic formula. Today our focus is going to be on how to derive the general quadratic formula. We will need a quadratic equation to be able to derive the general quadratic formula. We will need the quadratic equation to be able to derive the general quadratic formula. This is because the general quadratic formula is intended to solve any quadratic equation. It is the reason we need a quadratic equation to drive the general quadratic formula, so that the general quadratic formula will in turn solve any quadratic equation. Driving of this quadratic formula is procedural and it requires mastery of algebraic manipulation, and we'll be dwelling on using completing of squares. Now we know in our last meeting we've seen the form of the quadratic equation. We know the form of the quadratic equation. And we said that the form of the quadratic equation is ax squared plus bx plus c equals to 0. Ax squared plus bx plus c equals to 0 as demonstrated on the screen. Ax squared plus bx plus c equals to 0. And we say that the a is the coefficient of the quadratic x. The quadratic x is the one with x with squared on top. I mean, having the raised to the power 2, x raised to the power 2 is the quadratic x. And the a must not be equal to 0. If the a is equal to 0, it will make the equation linear and no more quadratic. We said if the a is equal to 0, it will make the equation linear and no more quadratic. So this is the form of the quadratic equation. Ax squared plus bx plus c equals to 0. Ax squared plus bx plus c equals to 0. And I said the a is the coefficient of the quadratic term, and the quadratic term is x squared. The power of the x, or the x must raise to the power 2 to be a quadratic equation. If it's power 1, it's linear, and if it is power 3, it's cubic. It must raise to the power 2, it must raise to the power 2 to be called quadratic. If it is to the power 1, it is linear equation, and if it is the power 3, it's cubic equation. Now the b is the coefficient of x, and this x is not a quadratic x. And the c there is our constant term. The c is our constant term. The c is our constant term. Now I said the a must not be equal to 0. If the a is 0, it would turn the equation to linear equation and no more quadratic equation. As seen in the next step, bx plus c equals to 0. So you will see that the quadratic term has vanished, because if the a is equal to 0, the quadratic term will vanish. And you can also see the example using numbers. 5n plus 3 equals to 0. 5n plus 3 equals to 0, which means that if there were a quadratic term, the quadratic term has vanished because the coefficient of the quadratic x is 0. Now we will be look at the example in the next step, which is 2x squared plus 5x plus 3 equals to 0. If you want to identify a in this case is the coefficient of the quadratic x, and the a is equal to 2, and the b is the coefficient of the x term, which is equal to 5. The c is the constant term. The c is the constant term, and the constant term here is 3, and it's all equal to 0. Is all equal to 0. Remember that the a must not be 0 in the quadratic equation. In other words, if the a is equal to 0, it will become linear equation. Linear equation. Now we want to see that there are few steps we will take in order to derive the general quadratic formula, and the few steps will involve normalizing the coefficients. Normalizing the coefficient. The coefficient here is the coefficient of the quadratic x. The coefficient of the quadratic x, which is a in this case. We'll actually look at normalizing the coefficient for today, and if there is a possible means, we'll also move to looking at moving the constant term to the other side of the equation if possible. The constant term here is c, and as we'll be doing the manipulations, you will see the constant term that will be moving to the other side. Now, if we want to normalize the coefficient, you will see that after the check mark, the second step, you will now see b over bx plus c over b equals to 0 over b. And 5 over 5n plus 3 over 5 is equal to 0 over 5. Is equal to 0 over 5 and is equal to 0 over b. All we intend round to 0. We will see that one in our next step, and that is normalizing the coefficient of the quadratic x. Good. So we see our quadratic equation. Ax squared plus bx plus c is equal to 0. Our quadratic equation, don't forget. So we are going to normalize the quadratic, the coefficient of the quadratic x, and we'll be isolating the constant term to the other side of the equation. Now, why are we normalizing the coefficient of the quadratic x? If the coefficient is 1, we don't need to normalize. If it is 0, it is not a quadratic equation. Again, if the coefficient is x, if the coefficient of the quadratic x, which is a, is 0, is 1, we don't need to normalize. If it is 0, it will turn the equation to linear equation. Now, when do we normalize it? We normalize it when it is greater than 1. For example, 2, 3, 4, and above. And when it is less than 0, for instance, negative 1, negative 2, negative 3, and so on. And so if the coefficient is any number other than 0 or positive 1, other than 0 or positive 1, we will have to normalize the coefficient of the quadratic x. And that is what we are doing. Now, normalizing it means that we are going to divide through by the coefficient of the quadratic x. And in this our case, the coefficient of the quadratic x is a. So we will divide ax squared by a, and we'll divide bx by a, and we will divide c also by a. We divide 0 by a. 0 divided by a will in turn give us 0. So you will see that ax squared is divided by a, bx is divided by a, and c is also divided by a, yielding x squared plus b over ax, which is in blue. The b over a is in blue, plus c over a is in red, is equal to 0. Now the b over a is called the coefficient of x, and the c over a is a constant term. Now the constant term, we are moving to the right hand side of the equation, to the RHS of the equation, is c over a. Now when we move it to the other side of the equation, it becomes negative c over a, negative c over a, negative c over a. After we have moved it, what we'll be doing is that we'll be adding the square of the half of the coefficient of the x term. The square of the half of the coefficient of the x term, or the square of half of the coefficient of x term. Now the coefficient of the x term, I said in this slide here, the last slide, x squared plus b over a plus x is equal to negative c over a. We said the coefficient of the x term is b over a. Now, half of it will be b over 2a, or half times ba, which will give us b over 2a. Half of it is b over 2a, as you will see here. And when we square it, it will become b over 2a all squared. b over 2a all squared. And we need, that's in the second step, and we need to add it to both sides of the equation. So we have x squared plus b over ax. Then we are adding half of the square of the coefficient of the x term, which is b over 2a all squared, to the left hand side, and we'll be adding the same to the right hand side. This will help us to be able to complete the square, and we can further simplify to generate our quadratic formula, the general quadratic formula. But today our focus is on normalizing the coefficient. We know our quadratic equation is ax squared plus bx plus c equals to 0. And we said that we needed a quadratic equation to be able to drive the general quadratic formula, so that the general quadratic formula will be able to solve any quadratic equation. Now remember that we said the coefficient of the quadratic x, which is a, must not be equal to 0. If it is 0, it will lead the quadratic equation to a linear equation. No more quadratic equation. No more quadratic equation. The b is the coefficient of the x term. The c is the constant term. And remember that we need to also normalize it, because we need to normalize the coefficient of the quadratic x, because it is any number rather than 0 and positive 1. If it is any number other than 0 and positive 1, for example, if it is a number other than 0 and positive 1, the number like 2, 3, 4, or negative 1, 2, 3, negative 2, negative 3, we need to normalize the coefficient. Normalizing means that we want to do away with the coefficient of the quadratic term, and we will leave only the quadratic term to stand, x squared to be standing alone. And so in all, we are saying that the quadratic, in summary, we are saying that the quadratic equation has the form ax squared plus bx plus c equals to 0. And we are also saying that the general quadratic formula is derived from, or is derived using the quadratic equation. We also said that the general quadratic formula can solve any quadratic equation because it is derived from the quadratic equation. The steps to driving the general quadratic formula include normalizing the coefficient, which we saw, moving of constant term to the other side of the equation, and adding the square of the half of the coefficient of the x term, which we have just seen for today. We will leave the rest for our next meeting. Thank you for joining this class. See you in our next class. Bye-bye.